Hello, welcome to section 4.3 Right Triangle Trigonometry, part 3, and where we will be working on modeling and solving real-life problems. So before we get into our application problems, let's just look at a couple of trig equations and make sure we know how to solve them. So we're going to solve for x. If it's a side length, we want to round to the nearest hundredth. If it is an angle, we want to round to the nearest degree. So side lengths, nearest hundredth, angles, nearest degree. Alright, so the first one we're going to look at is tangent of 25 degrees is equal to 14 over x. So to solve this equation, we want to get rid of the denominator of x. So multiply x to both sides. That would be x tangent of 25 degrees is equal to 14. And then here is where we can divide by that quantity, tangent of 25 degrees. So in your calculator, make sure you're in degrees. So you can see on my screenshot here, I made sure I was in degrees, and then I plugged in 14 divided by tangent of 25. And so that's 25 degrees. That's why you need to make sure you go to your calculator setting and make sure you're in the right measure there. So we get 30.0230969. Since it's a side length, because it's an angle, tangent opposite over adjacent, so we know it's a side length, so we know x is going to be approximately equal to the nearest hundredths. Tens hundredths is two places, so that's 30.02, and usually we would put a unit there, but since we're just solving general equations, we don't have one. Alright, on example 2, we're looking for an angle measure. Sine of an angle is equal to 4/5, or opposite over hypotenuse. So when we're looking for an angle measure, we use the inverse. So once again, we're looking in degrees, so make sure you're in degrees on your calculator. And then since you're looking for an angle measure, you're going to do the inverse of sine of 4/5. So you're working backwards, and you want to know what angle gives you the ratio 4/5. And so then x, since we're looking for a degree, is equal to 53.13, but we're rounded to the nearest degree, so that's 53 degrees. So some of your application problems are going to talk about angles of elevation and depression, so here's just a quick sketch of what that looks like. If you're kind of standing on this ground level here and you look up, that represents an angle of elevation from your line of sight to what you're looking up at. If there's a person above you looking down at you, then once again their line of sight and them looking down creates an angle of depression. These two angles are congruent to each other, so they will be the same value. And those are, so when we look at these applications, when it talks about angle of elevation and angle of depression, picture that line of sight and then either looking up for an angle of elevation or looking down for an angle of depression. So the first example we're going to look at is a lighthouse operator is 25 meters above sea level, sights a sailboat. The angle of depression is 10 degrees. How far is the boat from the base of the lighthouse? So all the things that we're going to be working with are right triangles. So here's our lighthouse. It's 25 meters above sea level, so we know the height is 25 meters. Sights a sailboat, alright, where the angle of depression, so here's this line of sight. So you're looking out, the angle of depression is 10 degrees. How far is the boat from the base of the lighthouse? So here's the base. How far is the boat? Well, this angle of depression is 10 degrees. That either represents, since it's a right angle, that's 80, or the angle of elevation from the sailboat up to the lighthouse is also 10 degrees. So either one of those is fine to indicate. I'll use the 10 degrees knowing that I have the information of the adjacent side, and the opposite side I know I'm going to use tangent. So we'll do tangent of 10 degrees, and the 10 degrees that I'm using is this one right here. So that's my acute angle of the right triangle. So tangent of 10 degrees is equal to opposite over adjacent. And then we need to solve that equation similar to the one we did in the beginning. Multiply both sides by x, and then dividing by tangent of 10 degrees. So you'll plug that into your calculator. So x will be equal to 25 divided by tangent of 10 degrees. Make sure you're in degrees. And then that will equal approximately, and we're looking for a side length, so we're going to round to the nearest hundredth unless it says otherwise. So x is equal to 141.78. And so the question is, how far is the boat from the base of the lighthouse? We need to indicate what that represents. So we'll say the boat is 141.78 meters from the base of the lighthouse. And that answers the question. Once again, make sure you are answering the question on each of these application problems. Alright, and the last example here is going to be a little bit more challenging, a little bit more going on this one. So let's take a look. To measure the height of a mountain, a surveyor takes two sightings of the peak at a distance 900 meters apart on a direct line to the mountain. The first observation results in an angle of elevation of 47 degrees, whereas the second results in an angle of elevation of 35 degrees. What is the height of the mountain? So there's two measurements being taken. So that's the first measurement. And then they'll walk 900 meters away. And that will be the second. So they're 900 meters apart. The angle of elevation on the first one is 47 degrees. And then of the second one is 35 degrees. So they walked 900 meters away. First observation 47 degrees, second one 35, and we're looking for the height of the mountain. So right here we'll represent that as the height of the mountain. Okay, so how do we kind of put all of this together here? We have two right triangles, so let's look at the 47 degree one first. We have this is 47 degrees, we know the height, and then our unknown of the base we're going to call x because we don't know what that is either. So that's using opposite and adjacent, so that'll be tangent. So we're going to say tangent of 47 degrees is equal to opposite over adjacent, which is h over x. We'll now create a second equation of another right triangle using 35 degrees. Now remember, we're using the right triangle, not just this triangle, but it's got to be the right triangle, so it has to be all of that. So that'll be tangent of 35 degrees is equal to opposite, which is still the height, but the adjacent is not just the 900, it's the 900 plus the x value. So we have two equations and two unknowns, so it looks like we're going to have to solve a system here. Let's go ahead and get rid of the denominator on both of these, so let's multiply by x. That'll give us x times tangent of 47 degrees is equal to the height. And then on this one, we're going to have tangent of 35 degrees times 900 plus x is equal to the height. So I took this equation and multiplied by the denominator of 900 plus x. So as you see, we have h equals and h equals, so we will be able to do substitution. And so we can say x times tangent of 47 degrees is equal to, I'm going to go ahead and distribute the tangent of 35. So that'll be 900 times tangent of 35. So we'll do 900 times tangent of 35 degrees plus x times tangent of 35 degrees. So we want to get the x's on the same side, so we're going to subtract x tangent of 35. Now you're not able to subtract these, they're not like terms, so you're going to have x times tangent of 47 degrees minus x times tangent of 35 degrees is equal to 900 tangent of 35 degrees. So the same way when we were solving algebraically, we were solving inverses, we had to do this point where we had two x's, we had to factor out the x, so we'll do the same thing here. So this would then be x times tangent of 47 minus tangent of 35 degrees. And now that we have x by itself multiplied by something, we can divide by that entire quantity, tangent of 47 degrees minus tangent of 35 degrees. And we'll do it to both sides. And so we have x is equal to that whole thing. Okay? So you're going to have to plug all of that into your calculator. We want the most exact answer that we can get. We don't want an approximation. So we don't want to plug in bits and pieces of this as we go through this equation. We want to solve for x and then plug it all in at once. So you can see over to the right here on the calculator, I have plugged in 900 tangent of 35, that's on top, it's in parentheses, divided by, and I guess it kind of got cut off there, divided by, well, I guess I thought, oh, here it is, divided by tangent of 47 minus tangent of 35. So I had to do it in two pieces there, that's why it looks that way. So 900 tangent of 35, that has to have parentheses around it, so it's going to have parentheses around this, divided by, and then parentheses around the denominator as well. And so when you plug that in, you will get approximately 602.22 meters. Now that's from the base of the mountain to my first sighting. What we want to find is the height of the mountain. So we have an equation up here. X tangent of 47 degrees is equal to the height. So we'll use that equation. X times tangent of 47 degrees is equal to the height. So we have what x is. And we'll plug tangent of 47 degrees, and that will give us the height. Now once again, I want to take that exact answer. I don't want to round the 602.22 from my previous. So if you look on the bottom screenshot here, I've taken the answer. So there's the button on the calculator that you press second, and then A and S, which is the negative sign on the graphing calculator. So second answer, and it'll take that entire quantity and not just the approximation. It'll take the entire quantity and times it by tangent of 47 degrees, and we get a height of 645.81 meters for the height of the mountain. So we will write that answer out. We want the height of the mountain to be 645.81 meters. And so that will be our final answer for that one. So you can see this one's a little bit more extensive. You have to set up a system of equations. Not every problem is going to be like this, but these are ones that will add a little bit more to it, a little bit more challenging. And then that is it for applications.